Hello and welcome to Azure Databricks. This topic we'll be covering is calling the Cognitive Services Vision API. My name is Brian Kafferke, and I do want to call your attention to the link at the bottom of this slide. All my content is available on GitHub, so github.com/bkafferke/shared, and you'll find this under Azure Databricks Cognitive Services, or I think Azure Databricks Vision API. So you should be able to find that, and you can just download that content and you're good to go. There's a lot of other content. All my videos are out there, and I do have a lot of videos out there on PowerShell and machine learning and things, and a number of videos. I'm starting to build a sort of collection around Azure Databricks, which has become really my favorite topic to cover these days. I'm really excited about it. It's such a great thing because it combines very easy to use big data centered around Spark with the machine learning languages of R, Python, SQL can be used with it, as well as Scala and Java. So you kind of get everything all in one. And with Databricks and Azure, it wraps it up in a secure environment. It allows massive, secure data science collaboration. And it's just great. And the notebooks are really good. We'll take a look at that in this demo. So we'll get to see a lot. So hope you stick around for the rest of this because it's pretty cool, really. I had a lot of fun working on this, and that's why I turned it into a presentation. So let me start by talking about what is cognitive services, because that's a good place if you don't know what it is. The bottom line is what they really are pre-trained machine learning models. But these are pretty complicated pre-trained models because Microsoft was able to put a lot of data through them and get them pretty highly tuned to do what they do. So that's the one thing. However, a pre-trained model is one that's trained for you and you don't have to do your own model training. When you work in machine learning and you train a model, you give it input data. If you're trying to predict something in the future, you would give it historical data, and based on the historical data, you train the model to predict future events, maybe like what sales will be in a month or 2 months, maybe whether somebody is likely to contract a disease or whatever you're trying to predict. But then there are other types that are trying to figure out, like with looking at text. What's the sentiment? Is a person angry? Are they upset, etc.? Now, some models are pretty generic. For instance, looking at a picture and saying, what's in the picture? Is it a dog? Is it a cat? Are there buildings? Is there water? That would be a fairly common use case, right? There's nothing very specific to an industry or to a type of discipline like medical versus finance or something. Other times, though, it can be very specific. You might be trying to look through genomes and figure out what sequence of DNA occur and maybe tie that back to some sort of a disease or do something like that. So obviously that's pretty specific. If you're trying to look at medical images and figure out if there's a fracture in a bone, again, that would be pretty specific. It's not something that a generalized model would be able to predict because it's the generalized by its very nature is general. Okay, so when you think of cognitive services available for AI, they're really designed to do those kind of general things. But this is very powerful because we can really use them in a lot of ways. For instance, as I mentioned, the image one we're going to look at today, lots of companies have all kinds of scanned documents. They have all these images that have handwritten notes, or they could scan them in if they don't have them already scanned. Handwritten notes, or maybe it's typed text, but it's basically embedded in an image. So that makes it really difficult to parse it out and make use of it. Other times you might like speech. Maybe people are talking. We'd like to take what's being said and turn it into text. And maybe we want to take that text and turn it into another language, take it from English and go to French or German, things like that. And that's all supported within the speech API. There's a service in here to build knowledge bases. There's another one centered around language, which is more the text orientation, and be able to do things like sentiment and figure out, or maybe figure out what's the category. What are they talking about? Maybe they're talking about medical things. Maybe they're talking about financial problems, etc. And then Bing is a very powerful search engine, and the Bing search capabilities are exposed as services that you can leverage for all kinds of really flexible and powerful search capabilities. Now I'm going to go to this link here, and this link will take us to a lot of really great documentation online. And we can see in here, start with the vision, that's what we're looking at. These are all these different types of services you can get. So we're going to be focusing here on these two, but you can see there's a video index, a custom vision, face recognition, identification, even a content moderator to sort of block content that you wouldn't want to, say, get into a website. And then there's a whole other category here for speech and text-to-speech and translation. And by the way, there's a app on the iPhone called Microsoft Translate, and that will actually allow you to speak a language, and it will translate it into text, and you can have it turn it into text in other languages, and in many cases not only turn it into text but then speak the text in a different language. So it's kind of a cool thing. It reminds me of Star Trek's, and by the way, I am drinking out of my Star Trek mug, so it fits the conversation. But it reminds me of Star Trek's Universal Translator, because you can speak anything, you can speak in English, and it will actually turn it in and speak in another language. So if you're in another country, you could actually use it to ask, like, how much does this cost? Where's the men's room? Whatever, those kind of common phrases if you want. So you get a lot of cool stuff here. This is the language piece, so a lot of text analytics and things, understanding language, knowledge base, and then a Bing search. And you can see there's a lot of Bing search capabilities out here. Really, really cool stuff. This is exciting. What's nice about it is you can go in here and just stop playing around. There's actually demos and things in there. And I'm going to focus more on the using the script code, because one of the places you'd want to use something like this, and it's a really exciting place, is you could take applications that traditionally have been kind of dull. You know, you can search for things, maybe you're finding favorite restaurants and things, but adding intelligence into the apps could really make it really interesting. And you can see it more and more. Companies will do that with their apps. They'll actually maybe interact with you verbally. They may give you, based on what you're trying to do, say, oh, I think maybe you're really interested in going here. So the idea of adding artificial intelligence is catching on big time, and I think it's going to just do more of that. And so now you have cognitive services, so you can have very cool apps that will do these cool things too. And one of the interesting things, when the search capability, the Bing search type capabilities were added to cognitive services, the team at Microsoft decided to do a really interesting use case. Around the same time, the JFK assassination files were opened up for general public to see, so they declassified. And so the Microsoft team pointed, sort of, I think it was like a big hose just sucking all these documents, and they put it through cognitive services, and cognitive services parsed and sliced and diced and pulled out anything that was, you know, in these images and documents, whatever it found. It pulled out any handwritten or typed written notes and extracted them and categorized them and did all kinds of entity analysis. It even took images, and it would even link images and things in text and do all kinds of cool stuff, so that you could really navigate intelligently through all this pile of documentation and make sense of it and find threads and patterns and things you want to look at. And I think that's a really common use case in a lot of companies. I know lots of companies I've worked at for over the years that maybe had rooms with all these, you know, past claims files for customers, or any kinds of documents, or even, you know, maybe in some medical cases, there's some older documents and things that you still need to keep. Could be doctor's notes, could be medical records, etc. You might want to take those and turn those into searchable, usable text, or put them into even a more structured format. So there's a lot of opportunities here, and I like this use case because this is kind of something I think a lot of organizations need to do. Like, okay, we got a pile of stuff, point it at this, ingest it, and make sense of it. So there's 2 links there that you can go to. Again, go to my slides on GitHub, and one is a video that talks about this JFK use case and how they came about. And it's very interesting. This other one is a blog that kind of gives you more information about it, and I think there's some sample code that you can play with or whatever and look at. So take a look at those. And I like that, though, because it does give you kind of an interesting sense of, like, how could we use some of these things and put it together. We saw this. We're going to be focusing on the computer vision piece of this, and in particular we're going to be looking at the optical character recognition and handwriting. Now, the first thing we need to do before we can use cognitive services is add it to our subscription. So what I want to do is go into my portal in Azure, the Azure portal. I'm going to say create a resource, and then what I'm going to do here is say computer, and computer vision comes up, so I don't even have to finish typing, and it tells me, okay, what it's doing. Notice I'm going to computer vision. I need to specify the sort of category that I'm looking at for my service. I don't just say all of cognitive services. Here I'm looking for the computer vision. Now say create, and I give it a name here. I can tell it what subscription, what location I want to put it on. I'm in the Boston area. East US 2 is good. Pricing tier. And then, do I want to use an existing resource group or a new one? So I would generally recommend, if you're playing around, put it under a new resource group. A resource group is just sort of like a container or a box, and everything you create is going to go in it. So Cognitive Services has to create probably a bunch of things. I don't even know what it creates under the covers. So if you put it all in one resource group, if you don't want to use it when you're done, you're ready to not have to pay anything or whatever, and you want to get rid of it, you can just delete the entire resource group. So it's a really good idea to do that. Now, I'm not going to create another service because I don't want to keep consuming so many resources at Microsoft, even though I work there. So instead, I've created one just for this purpose, and it's called bCAFE Computer Vision. And I'm going to go into that. And notice it goes to Quick Start. And I'm not going to show you this because that would not be a secure thing to do. But you will need to grab the keys related, or I think really just one key for the service, because when you call it, it needs to use that to link to your subscription and authorize you and let you connect to the service. So that's the kind of the point there. Don't forget too, though, there's lots of good documentation. So, really make avail of that. A lot of times I even tend to overlook it, but there's some really good documentation around this. I think the Cognitive Services documentation, the API stuff, is actually really good. It's pretty good and covers it well, so you can actually jump in and get started. If I could do it, you can too. Coding stuff here and the documentation on coding. So really good stuff. Take a look, have fun with that, and let me jump back. Not sure where we are. Let's see. So kind of refresher here, creating the computer vision service and linking it to your subscription. And just a reminder about that slide. Get the key. Don't forget the documentation. And before I jump into my riveting demo, I want to point out that not only Python is supported, but you can use a direct REST API call if you like to do this with curl. You can use C#, Java, JavaScript, Objective-C, PHP, and Ruby. So lots of different languages supported. Not sure about R. It's interesting. I'm curious about that. I'm guessing there is a way to do it. I'm probably using the REST API in R. You could also do that. As long as you can call a REST API, I believe you should be able to do this. So let me get into my demo, and I do want to point out, if you get the slide, you'll have these links. So this link just takes you to some of what I've already been showing you, but this shows you how you can use online demos. So if you want to play with images, you can actually upload your image, and it can tell you what's in the image. There's facial recognition ones, all kinds of ones you can play with. If you've used Windows 10, I actually have on my Surface a facial recognition, so it always checks to see, is it really me? And it's pretty intelligent. If I'm wearing my glasses or not, it still knows it's me. So pretty impressive, actually. It does a good job with that. And this other link brings you to some sample API code, so you can find the sample code, because there's so much documentation, sometimes it's hard to find exactly what you need for code. So let me jump over to the demo. So I've already got Databricks running. If I didn't, I can just go here. Got a whole nother demo out there, or a video. Go look for my Azure Databricks overview, and it talks all about how to create the service. So highly recommend it. It's the most exciting, fun thing to work on in a long time. So go out and check it out. But you could click right here and start it. Since I'm in there, I'm going to jump right in. And going into Workspace, I bring up my notebook. And I'm not really here to talk too much about notebooks, but notebooks are much like Jupyter notebooks. If you use those, a notebook's a way to write code in a machine learning world. Azure Databricks notebooks are specific to Spark. So Databricks is a built-in portal, if you will, within Azure, which provides a completely integrated, collaborative, secure, Active Directory secure, etc., environment that for machine learning collaboration based on the Spark platform, because Spark is the hottest and most scalable big data platform out there, and it's open source. So this is really wrapped around open source. And the founder, one of the co-founders of Databricks, wrote Spark. And they are the largest contributor, as far as I can tell. Like 80% of the stuff that goes into Spark itself is coming from people at Databricks. So they're huge supporters of Spark, and yeah, so it's great. So what I'm going to do here in my notebook, you get one of the things you get that's kind of cool is you don't always have to do a markdown cell. Just point out, you can actually have these titles. So I can say hide title, or I can say show title. And it's kind of handy because it means that you don't have to keep typing all these markdown cells. And markdown cells, I'll show you somewhere in here, is just a way to put annotations and comments into your code. So what I'm going to do, I want to point to blob storage. So a piece of this is useful if you just want to know, how do I get to blob storage from within a notebook? Now, I'm going to show you not the most secure way to do it, to be honest. There's a way to set up secure, what you call secret keys, and do it more in a more secure way. I'm going to do it in a little less secure way, but it's the basic principle is the same, because what I'm going to do is create a mount point, and that's what I want to kind of cover. So I'm using Scala to do this, frankly, because that's the code sample I found. So I'm using Scala, which is fine. And all I'm really doing is creating some variables here. Now, these variables are pulling from widgets, and that's a feature of notebooks. And these are my widgets. So I've created these, have these widgets available, and I can enter sort of the variable parameters that I need. And these are bogus values, so don't try them at home because they're not going to work. But these are just gives you the container name, count key, blah, 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 and you can use these. And then what I'm going to do is I'm running this piece of code, and the goal of this particular line is to use those variables above. You can see the blob configuration and blob account key. And what it's doing is it's creating a mount point, which essentially creates, so let me back up for a minute. Azure Databricks has within it a local file system. It's called DBFS, Databricks File System. So within that, I can upload and work with files there, or I can create what they call mount points, which are essentially local name references to my blob storage. So what I want to do is under DBFS, MNT is typically used for mount, and then I can just create a logical sort of tag or subdirectory name, and that will now be how I can reference what I have in blob storage. So it's really handy. Once I've created the mount point, this name, it's just like it's a local system thing, and I don't have to do it anymore. And for that reason, I'm not going to actually run this code right now because I've gotten rid of the proper code I need to make a real true connection. But that's okay because I've already done this earlier, so you don't have to keep reconnecting mount points. So here I'm going to just use, this is one of the file system commands, so the magic is %fs, it tells it the cell is file system. And I'm just going to get a list of files that are on this particular blob storage. And you can see I've got these two images of what I'm going to be using. Now this image, this is just a markdown cell, and I'm just referencing an image, so I can just do Shift Enter and run it. But this is what I'm going to do. It's a very simple one. I just created it really in Paint for what it's worth. And I just said, this is a test emergency broadcast system. And I want to see if I can get the code that I pulled out of Microsoft's examples, if I can get that to pull the text out. So I'm going to use a magic. Now notice this notebook is a Scala default notebook. So that means when I don't use Scala, I have to give it the magic to tell it what the cell type is. Nice feature of Azure Databricks notebooks, though, is you can use any language supported by Spark within the notebook, which means you can use Python and PySpark, R and Spark R and Sparkly R. SQL is built into Spark, so that's supported. You can use Scala, you can use Java. So you got a lot of flexibility there. And you can mix and match and use things between them. So I'm telling it it's Python. And then I'm basically just importing a bunch of modules. So a lot of imports here going on. Matplotlib, the Pillow library, or Pill, all this IO stuff, Matplotlib, some things in there. And I need a subscription key. Now I'm not giving you the value in a different cell somewhere that you can't see here. I put my subscription key, and this is the key value that we were talking about from the Cognitive Services Vision API. So that's where you click on the keys and you would paste that value in here, in quotes. I just have it as a hard-coded thing here. Yeah. And then I've got this. Okay. And then what I need is the URL. So this is the URL to get to the Vision API, or at least to get Cognitive Services, and I want OCR, so I'm tacking that on. So that's going to add to this, the OCR link. Then I'm telling it, where's my image? And then this is a bunch of settings that have to do, it's basically a JSON settings that are going to tell the service, what do I want to do, like what language is it, and I'm saying it's unknown, so I'm letting it determine it. Again, using keys. This sets up essentially a JSON, I believe, type of file, setting up response. And here I'm taking the response and getting the JSON. And then I'm just basically going through here and calling it. And what it does basically in the background, and I'm not an expert on these things, but it's essentially looking through the image and creating boxes around what it thinks are words. And then I'm kind of looping through all that. And at the very end, this piece is not needed. Originally, all 3 lines were used so that I could put the image behind the text and it would look kind of cool. That's what the Microsoft example does. But in the end, I just wanted to show that I could really pull the text out. So I simplified it. So I'm going to comment that out. So that really isn't needed for this. And then I've got this going on. So let's see if I can run that. Okay, and it worked. I can say this is a test of the emergency broadcast system, which you can see that's what it is. Riveting, I know, really good. For your stuff, mileage may vary. I don't know how hairy it might get and what you're trying to do, but generally OCR shouldn't be too bad. This is probably going to be a little more challenging. It's a fairly good sample. I found it online. I just grabbed it and plugged it in. But this looks like fairly good text. I have not had a chance to test it with really bad written handwriting. If I tried my own, I don't know how it would do. But again, Python again, and then this time I'm doing handwriting, pulling in a lot of the same libraries. Mostly this is exactly the same as before. One slight change: if you're using a Jupyter Notebook, you have to have this %matplotlib inline so that it will output graphics within the notebook. But we're in Databricks, we don't need to do that. Again, subscription things. Again, the only difference here, and it's the same link except now it's recognized text is added to the URL. We're telling it the image path. And notice again, DBFS is the parent of the mount point. So we didn't really reference that when we created the mount point, but here we do need to tell it. It's DBFS, and then it's MNT, blob images, and then we can get our data, so it's going to read it from there. And again, creating the parameters and things needed. And then we just say there's a response URL. And feel free to go through the code, but here we're going to be, this is actually asked, it's calling it, but you have to loop through, and notice it's doing a sleep. So it's waiting for the service to finish it because there's more work going on in this particular case. It's got to figure out what did you write and compare it to historically what they used to train the model, essentially in there. So it's going to try to figure out what you wrote. And here it's doing a similar thing before, I believe. It's creating bounded boxes around the text. And then here we can just go through and extract that. So run that. Okay, so it took a minute, and you can see it's going here. Now I should point out, if you notice, if this were leveraging Spark, you would see it would have Spark output. So this is really just using local system resources to make this call. I'd have to look at more closely how I could scale this out and set it up so that Spark was actually doing the work. Not sure how easy that would be. I'd have to learn more that I know currently about calling out, because ultimately I'm calling out a URL service. So I guess there really wouldn't be a lot of benefit there. We're not asking Spark in this case to do the work. We're actually calling cognitive services, and it's doing the work. So yeah, probably not a lot of benefit in this case to doing it in Databricks. Just accept it's here and you can do it there, and I wanted to prove it could be done. And this is really anywhere we can run Python, Jupyter as well, you could do it here. Yeah, so that's really a matter. Now when you do subscribe to the cognitive services, you do have to tell it how many calls you pay based on how many calls you expect to be allowed to make per day to it. So make sure you pick something appropriate. All right, so that's my presentation on kind of a combination of Azure Databricks, cognitive services, and then specifically the Vision API. Hope you've liked it, and let me go back to my slides. I hope that covered everything. Again, don't forget the links and everything and on GitHub. So wrapping up, the first thing I want to say is that one of the easiest ways to jump into machine learning and the cool world of AI is to use cognitive services, whether it's through API calls or direct REST API. You could use the REST API, etc. It's a cool way, and even just going through the demos and playing with it is kind of fun and cool. Somewhere out there I saw one, I don't remember exactly, but it actually guesses your age. I'm a little afraid to try that. It might tell me I look older than I am, but it's kind of fun. There's many useful models out there, and then again, they're pre-trained, so that's nice. You can jump in and get in quickly with these models if you're looking to get into AI quickly at your organization. Again, make use of the online demonstration sample API code. It's really cool and just really not difficult to get into. It's, like I said, it's the easiest entry into machine learning and AI. So take advantage of it. I hope you like this. Please subscribe, share with your friends, and I'll see you next time. Thank you.